details of the customers who have ordered something today. So I will write some query to fetch the data. This command that I will write to fetch the data is called as query. Just asking the database for the data that I want is a query. Okay. And structured query language is a query language again that we came up with in the 1970s. This is the language upon which the relational database nowadays are focused on, based upon actually, and Microsoft SQL Server, PostgreSQL, MySQL, all of the database management system use this common language, that is structured query language. Right, the language we use to talk to a database and ask for information, that is run our queries. So it is not a programming language, it is a query language. Okay, and this is a very basic example of how you can retrieve data. So here it is written, select star from customers where city is equal to New York. So this particular query, when I will write, it will give me details of all the customers who live in New York. Okay, this star here denotes all fields. Can anyone here tell me what is the field? Is it a row or a column?
Column.
Column.
Column, great. So if I want to get all the columns, I write select star from the table where city is equal to New York. Now don't worry about this query right now. We will understand how we write is, why do we write select, why do we write where. This is what we will do in detail in the coming sessions. Right now I just want you to understand what SQL is about. The language is structured query language, SQL, and it is used to retrieve data from the database. It is not just retrieval. You can delete the data, you can update the data, you can even create tables, and you can create relationships. A lot of things you can do by using the language. You can change a lot of things in the database. Now moving forward with something that is called as schema, and schema is the structure of the database. That will include the data tables, as you can see here, the relationship and all those things. So relationship is being established using a common column, and as you can see, this is, let us say, my company. So I have the employees table, I have the department table, and I have the project table, and this is how they are related. So this table is related to this, and this table is also related to this, but these two are not related to each other. So here you can see that department ID is the common column. That is why we can create a relation. Project ID is the common column. We can create a relation. In these two tables, can you find a common column, project and department?
No.
That is why you cannot establish a relation. So that is what relational database is about. This is schema, that is the structure of the database, and this is example of a relational database. I have different tables, they have different fields, and there is relation between the tables. What is the benefit of this relation? If I want the name of an employee along with his department name, so name is in one table, let us say the name is Abhay, and department, let us say HR, is in different table. But because there is a relation, I can write a query and I can get the name of the employee in HR, and that will give me Abhay as the final answer. If there was no relation, first of all, I will find department name HR. I will check if the department ID it is 3. Then I will go back to this table. I will search where the 3 is, and then I will find the name of the Abhay. So this is actually what happens in relation also, but by creating a relation, the SQL by default will give us the answer instead of us doing manually, going through all the data, retrieving the name of the person. So it saves us one step that we will have to do. Now,
Sir, can you please repeat the previous slide?
The schema part?
Yes.
Okay, I'll explain it again. So schema is basically the structure of the database. Okay, and it will include all the tables. So here you can see we have the employee table, department table, and project table. It will include all the fields. So fields are your columns. So here your columns is name, job title, phone number, salary, department ID, project ID. In the department table, we have department ID, department name. In the project ID, we have project ID and project name in the project table, right? And relationship is between employee table and department table, and between employee table and project table. right? Why there is relationship between these two tables? Because we have a common column. In these two, can you tell me what is the common column?
Department ID.
Department
ID.
ID, great. And in these two, what is the common column? Project ID, right? So we can create the relations here. Now, why do we need to create the relation? Let us say, I want the name of all the employees who are working under my project. Let us say project name is AZC. This is my new project. I'm working on this software and I want name of all the employees who are working in the same. Now, the manual way is that I will first check, I will write a query and get the project ID. So I will write give project ID where project name is AZC. It will give me project ID is equal to 4. And then I will, in this table, I will write give me the name of employees who have a project ID is equal to 4. It will give me name of all the employees. So I have to do two steps. First, I get the project ID of AZC. Then using the project ID, I get the name. But if I create a relation, I can just write a single query by joining the two tables and I can get the details directly in a single query. So that is why we create these relations so we can skip this step and get a lot of data. It might seem simple to you that skipping a step is not a very big deal, but when we are dealing with lots and lots of data, like this is a very small database. In reality, there are lot of tables, lot of columns and lot of rows, and rows just keep getting updated if the database is live. So in case of, let us say, your UPI transaction database, your Amazon database, whenever someone is ordering, the database is getting a new entry. It is just getting updated time and again. It is not like a Excel file which is saved somewhere. It is a live database. Whenever I will order something from my Amazon, in the Amazon orders table, there will be a new entry with my name, my phone number, my order details, everything would be updated. I will make the payment in the transaction table, there would be a new entry. So this is not just storing data, it is mostly live data stored a lot of times, and there is relationship between the tables so that when you want to fetch the data, you can do it very smartly and efficiently also. So that is what schema is about. So I explained a lot of things here, but whenever if someone asks you what is the schema, it is the structure of the database. In very simple terms, if you want to remember the definition, what is schema? It is the structure of the database. Just remember this diagram and you are good to go. The topics that we are covering in this session, you will understand them in detail when we will do the hands-on practice. But I will share this PPT in the LMS too. Whenever you are going for any interview or you just want to revise the theoretical concepts, go through this. You should understand at least what these things are, because interviewer might ask you what is a schema, what is the difference between a relational database and a normal database. So these kind of things you should be able to understand.
In LMS, where are these files are available? Because I'm searching.
In LMS, you like in most of the cases when a particular file is for a particular session, like this particular PPT I'm using in this session. So you will open the LMS, you will go in, you will click on the name of this recording, like session 1 SQL date and those there. Below the video, you will find this file. Within that session, you will find the file.
Okay, got it.
Okay. So now moving forward with norm. Yes, Om Prakash, you have written hello. Any question in doubt?
Someone asked you LMS portal.
Yes, I think I answered it. Was I was on mute or something?
But he's not explaining. I will guide you and you give me permission. Can I guide him? Here not. Telegram.
Yeah, later on you can guide him whenever you want.
Yeah,
Like you can message him and you can help him out on Telegram, not an issue.
you can say him. You give me text message. Then after I will guide you.
Yeah, sure. So you can text Om Prakash. He will help you out with the file in case you want.
Sure.
Okay.
Okay, so moving forward with normalization, which is not something that data analysts would deal with a lot of times, but you need to understand just what it is and why it is used. Like if you were going into a backend development, like those kind of things, then you have to understand this in detail and 1NF, 2NF. But that is not the scope of what we are discussing now. Normalization basically means a way to organize a database to reduce redundancy, right? So here you can see in this employee table. First of all, do you know what is redundancy? It is duplicate data as written here. So in this employee table, can you tell me what duplicacy or what redundancy do you find? What is something that you feel repeats?
Manager ID.
Manager ID. Yes, you can see it is repeating again and again. Right.
Yeah,
And
sector
sector
IDs
ID is also repeating again and again. But this will happen. Like this is a normalized database. This is the basic that will happen. But if I were to merge these three tables, instead of creating three tables, I create a single table. What I can do with manager ID, I will write manager name again. So with one, I will also let me create this. I think I should have created his table to show you. So let us say I expand this table. I write sector name, then manager name, then area. So whenever I will write this manager ID 1, I will write Adam A and his area east. Then I will again write Adam A area east, Adam A area east. For 2, I will write Betty B west, Betty B west. So this basically is your redundancy. Right, one column you need because you want to fetch the details from the other table. So the common column would always be there. Like here, manager ID is the common column. So only manager ID is getting repeated. This is not a problem because we need one table. But if instead of manager ID, I have all the details in this single table, like manager details also, sector details also, right? So what will happen? This thing will again and again pop up in this table, like Adam A, Adam A, Adam A every time. Every time any employee has a sector ID 4, in this particular table, we will add finance, finance, finance. So instead of getting this redundancy in the data, we create separate tables, and this is called normalization. Right. So the example that I gave you earlier, if I have a product table, right? Let us remove product table. Let us say I only have a orders table right now, no product table, only orders table. So in every order, I write all the details like order number 1, quantity, price, everything. Like let us say someone ordered Lenovo laptop. I will write all the details. Then second order, another person ordered Lenovo laptop. So I will write all the details. Weight, a price, battery capacity, screen size, all the details. So this is your normal thing. But if you want to normalize it, you want to remove this redundancy of everything repeating again and again, you can create a product table. Right? You can create a product table and you can write the product details here along with the product ID or the name. So whenever you want to get the details, now in the order table, you will only write about the order and the name of the product. Let us say Lenovo. So now you can only write Lenovo, Lenovo, Lenovo. You don't need to write all the details about screen size, everything, because that is stored in a product table. Whenever you want to get the product detail, you can fetch using the column and you can see, okay, Lenovo, I can get the details from other table. So is the case here. If you want to get details of the manager, there is another table where you can get the details of the manager. You don't have to write it again and again. So this is the normalized database. Why it is normalized? Because there is no redundancy at this point. Okay.
No. One employee and second manager.
What? Any doubts, any questions, guys, in this?
I can say here is a 2% available detail, like one employee and second is a manager. Yeah, 2%, both person available detail, no?
Yes. So this is correct only, but there is no dependence that is duplicate data. Let me give you an example. Let us say here I add, again I will explain it. Here I add the manager name also in the same table. Then for manager ID 1 I will write Adam, Adam. Then for 2 I will write Betty, Betty, Betty. So instead of creating this whole big table, because I can store all these detail in a single table also if I want. I will need 1, 2, 3, 4. I will add sector name, I will add manager name, I will add area. So 7 columns and I will store all the details. But instead of storing it like this, I create 3 different tables so I can save the space by reducing the amount of data I am repeating. Okay, so I hope it is clear now. Moving forward, we will understand what a transaction is. So I think you already know, you go through a lot of transaction, but the theoretical definition of transaction from a database point of view is that when a transaction occurs, either everything will go right or everything will be cancelled. And this is very important for database to make sure that there is data integrity. So whenever you, let us say, like in UPI also, if you make a payment and the payment is not received, then you will get the message that your amount will get refunded or you will get the amount back in your account if it has been deducted. So if there is any issue, then the complete transaction is cancelled. If you go into a ATM by any chance and you put your PIN, you type the amount, and then later the cash is there, the cash is not there. In that case, your amount, if deducted, would instantly be getting refunded, or it will not even, the transaction will not even happen, right? So that is very, very important to maintain the data integrity, because if I have 2000 and you have 5000, so the total amount in the system is 7000, right? Now let us say I send you 20, I send you 500. So I'm sending you 500. So my new balance is 1500 now. But the transaction, like there is some error. So at this stage, if the transaction fails, the total amount in the system would be 6500 only. So this 500 rupees difference can create very huge problems when we are dealing with data. That is why a transaction by default means either all of the operations will succeed, even if one of the operation is not successful, all of the operation will have to fail, right? This is not something that you as a data analyst would be dealing with. Again, just remember what a transaction is and why it is important. It is important to ensure data integrity. Example is when you withdraw from the ATM, and if you don't get the cash, then your money will not get deducted from your account. Okay, a few more definitions before we move forward with particular things in SQL. One is big data. So you must have heard about big data. Before going into the same, can anyone here explain or tell what they think or what they know about big data? Like definition or whatever thing comes to your mind when I say big data. What do you think about it? Like what things
I
come to
guess, I guess, I guess if there's a rules like CR rules, in that case, it is a big data. It's like a retail bank database
Okay.
Huge data.
or any transaction database like UPI. Yes.
There is no such thing that it has to be a UPI or transaction or e-commerce. It could be anything. By definition, big data means that they are extremely large, and there could be any definition for extremely large, right? It is kind of subjective. You can say that 100 rows are large, then you can say no, 1 lakh rows are large. So when we talk about big data in terms of databases, the idea is that the data is so big that the traditional databases might struggle to manage it. So you need special tools, and these special tools are your Hadoop or PySpark, if you have heard about them. So when we say that the data is so big that even the SQL databases are not able to handle it, then you need certain tools to make sure that it is being handled correctly. So there is no fixed definition like 2 TB, 5 TB, 100 TB, 100 trillion TB. Basically, the idea is that it is so large that traditional databases cannot handle it. Or sometimes a single computer cannot process it. You need multiple computers or supercomputer to deal with the data. Example is a Facebook, Meta, even Amazon. They have so much amount of data that they struggle. If you will ask like Amazon to create, save all their details, even in SQL, it is very, very difficult because they have too much data. Zomato, Swiggy, Meesho, BookMyShow, Paytm actually have a lot of data, but BookMyShow, IRCTC might still use SQL because the data is not as huge. But when we are dealing with like if you compare the data that IRCTC have to the data that Instagram have, there is a huge gap. Instagram has lots and lots of data as compared to IRCTC. So Instagram might not be able to just store it into a basic SQL server. IRCTC might. So that is the difference. When the data cannot be processed within the traditional databases, the scope is so big that it cannot be stored in a normal database. We need special tools. Example is Hadoop. Then it is called as big data. Okay. Again, data warehouse. So data warehouse is also one more definition in the box that we have to deal with. And it is a large store of data collected from many different sources, often used for analyzing and reporting. So data warehouse is just the same as a warehouse that you have. So in a warehouse, you get logistics, you get luggage from different parts, and it is stored in a central warehouse. Same is with data. So if you have a, let us say, Starbucks. So you have Starbucks in let us say Mumbai, you have a Starbucks in Delhi, you have in Lucknow, you have in Pune, you have in Bangalore, you have in Hyderabad. So multiple chains, but not all of them have a data analyst, right? In a Starbucks cafe, there is a someone who is serving someone at the counter, but there is no data analyst sitting, right? But Starbucks would have a few data analysts to analyze all the data, what they are selling, how much they are selling. So the data is being collected from different sources wherever the order is being placed. MongoDB is also used for big data. Yes, MongoDB is used for big data. Mostly NoSQL databases are used, but there is no such criteria. Even NoSQL databases like MongoDB might struggle at some point, and you might need special tools. So again, data warehouse, data is getting from different places because someone is placing the order in Hyderabad, and the counter is being updated, like the details, the name, the phone number, and in different places data is being generated, but it is stored centrally in some place where the employee, the Starbucks data analyst, is analyzing the data. Yes, Nilesh, you have raised your hand. Any questions?
So for big data, we need special kind of queries. What queries we are using SQL, we cannot use in big data. What is setting here to another tools.
Yes, so when we work on big data, we cannot directly use SQL in the same, because by definition it means that traditional databases like SQL cannot handle that much amount of data in a, in a way. So we might need some special tools, maybe programming languages and some libraries within them like Hadoop, PySpark, to deal with the data, which is not a very common thing to do. Like big data is something that only very large companies will have, and even when you are working as a data analyst or someone, you will not be working on a big data, because that is mostly job of a data engineer or a cloud engineer kind of person. If you are working in, let us say, a very large company that is having big data and you are a data analyst, they will give you some part of the data, or they will filter out the data, they will store it into SQL format most probably, and then you will get the data to analyze. It is not that big data cannot be stored in SQL. They can patch it out, they can store parts in SQL, but the complete database, the whole data cannot be uh, kept live, kept hosted on a normal SQL server. It will require some special tools. So that is what big data is about. Yeah. So it is by definition the same. There is no such limit that it should be 1 GB, 2 GB, but basic idea is the same. It is not a very strict definition, but in general, we say it like that. It is so used that we cannot use the traditional databases. Now, CRUD operations are again something that someone might ask you, what is CRUD operations? So these are the basic operations that you can perform on a database. Very simple. C stands for create. You can create tables. You can read the data. You can update the data, like modifying, like changing the phone number of someone, and you can delete the data. So you can see the examples of contacts on your phone. You can add a new contact, you can save someone number, you can look for someone's number, you can update their number, and you can delete their number in case they are no longer your friend. So these four operations are CRUD: create, read, update, delete. And this is something that you can do with the data. Now, with all this information that you have, I will give you 5 minutes, and I want you to create a database for a coffee shop chain, and you have to create product table, customer table, and sales table, and what fields you will have in the same. Again, I hope you know what a field is. Is it a row or is it a column?
Column.
Column, correct. So you have to just create this table and just give 3 to 4 fields in all of the tables, and that is all. So you can write in chat box like product table, and what we have is customer table and sales table, and what kind of table names could be there. Try to keep some common columns so that you can relate the databases, and that is all. So I'll give you till 8:55 or 8:56 to write, and then we shall move forward with some other topic. Okay, till this point, any doubt, any question, or are you doing this? Do you feel how to do this? Do you feel any confusion in what I'm asking you to do? Anything that you want to ask? Okay, I think the answer is no. So I'll be waiting for your response in the chat box.
Hello. Hello.
Yes, Imran, you want to ask something?
Yeah. Actually, I want to ask about what is the use for BigQuery? Like it is under comes on big data. Hello, am I audible?
Yeah, yeah.
I mean, what
So
is a
big
BigQuery? Like it is comes under big data work or it is something else?
See, big data is a concept that is there. BigQuery, I suppose, is a particular a technology that is used for big data, and I think it is a part of some cloud platform. So if you look for cloud platforms like your Google, AWS, Azure is there, these cloud
Mm-hmm.
have their separate compatible features when you're dealing with big data, because mostly big data is being hosted on a cloud platform only. So
Okay.
Google has its own, and I think they name it BigQuery, and so is the case with Azure and AWS, they name it differently. So it is,
Okay.
yeah, it is kind of a data warehouse, and you can manage big data, you can store big data. And a lot of time, what the companies are trying to do, like the cloud companies, your Azure, your Google, and your Amazon, is that they store the data in a like in big data format, obviously not in SQL. But when you are interacting with the data, they try to make the syntax as closer to SQL as possible, so that if you already know SQL, you can still deal with the data.
Okay, got it.
Yeah. So I
Thank you.
hope you understand this particular part, that it's stored in some different way, but the language is same, so that you can at least get something out of the big data, even if you don't know the no SQL or the other languages, you only know SQL, still it is a lot more simple.
Okay, okay. Got it. Thank you.
Okay. So I think people are writing in the chat box. Just allow me for a moment. I'll just have a sip of water and then I'll be. Two of the students have answered in the chat box. I'll go through. So, Nilesh and customer ID, name, location, phone, page, package, in the product. Okay, great. Product table, product ID, product name, price, and sales has the customer ID, value, mode of payment. Great. Lokesh has written product ID, order ID, product details. Good. Customer ID, customer name, customer details. Correct. Sales table, order ID, region sales, sales. Okay. So, Lokesh, when we are having sales table now, we will have the order ID, but we will have a particular row in the table. So sales by quarter is an aggregation, right? So when you will create a sales table, whenever there is a sale, the table is updated. So sales by quarter is not something you will have, and regional sale is also not something you will have. Like
Okay,
you
so
are looking from a data analyst perspective, that you will analyze the data in certain way, but sales table will have single row entry. So in a single row, you can have the order
Mhm,
ID, you can have the mode of payment, the total price, the
mhm,
total quantity, and these kind of things. Sales table basically will have the order details.
okay.
Okay, Gautam has written customer name, phone number, location, date of visit, product name, number of sale, product ID, and amount of the product, sales number. Okay, sales have number of sales. Okay, fine for now. So let us move forward. I think, shall we move forward, guys?
Yes.
Okay, great. So now we will move forward with some more topics, and okay, we are good to go. So two things that we have is OLTP and OLAP, again theory for today. And OLAP is your online analytical processing, online